Okay, guys, so we're going to jump in. First thing we're going to chat about today is algebraic expressions. Now, obviously, we have spoken about this already, but again, it's really important for us to get this foundational stuff. And the reason that I want to go over it again is because obviously, as we move up into like grade 9, grade 10, we sort of expect you to know certain things. And so I expect you to know what terms are and how to identify terms. I expect you to know how to distribute, etc., etc. And so we won't necessarily focus on this stuff. I just expect you to know it. And so this is why it's so important that we sort of practice this stuff and become comfortable with it. So algebraic expressions, the first thing we're going to chat about is essentially when we talk about simplifying things. So the instruction when you're working with an expression is going to be simplify. Algebraic expressions are made up of terms, and importantly, terms are separated by plus and minus signs. So that is how we identify the different terms in our expression. And it's also going to be very important for how we go and simplify our expressions. Now, when we go and simplify expressions, we want to first identify the terms that make up our expression. We then want to simplify each individual term because terms sort of are separate to each other. We can then look at the expression as a whole and add and subtract like terms. But if a term can be simplified first, that's what we need to do. Okay, so if we go and have a look then at sort of the expressions that we have here, there are a couple things we want to be able to do. So I'm going to look at this first one here, and I'm going to ask you some questions. You can raise your hand or you can put it in the chat. But if we look at this first expression in A, we've got 7xy plus 3xy plus 5xy. So my first question to you is, and again, you can just pop it in the chat if you want, how many terms are there in this expression? Excellent, Tandor. So Tandor's put on the chat. See, Claire, do you want to let us know? Oh, no. Okay, I'm hoping that Claire would have said the same thing. Bridge has also said there are 3 terms in this expression. Now, we know this because remember I said that terms are separated by plus and minus signs. So those 2 plus signs are separating my terms, which means that I've got 1, 2, 3, that was weird, 3 different terms here. Now, according to my sort of set of instructions is I want to identify the terms that make up my expression as my first step. So I've done that. Now I want to check if I can simplify any of these terms. Well, there's no distribution in any of these terms. There's no division. There's no exponents that I need to deal with. So these terms are each simplified as far as possible. So technically step 2 is done for me. And so now what I want to do is I want to add and subtract any like terms that I have. Now, can someone remind me, and again, you can raise your hand or you can pop it in the chat, what are like terms? What do I look out for when I'm talking about like terms? Okay, Tandor, what are like terms?
Hello, ma'am.
Hi.
So like terms are like are numbers with the very same wait, is it exponent? No, numbers with the very same expression.
Okay, what do you mean by expression?
I meant to say variable.
Excellent, well done. So like terms are terms with the same variables. Importantly, when we do start working with exponents, it'll be the same variables and exponents. But essentially what we're looking for is that they have the same variable or groups of variables in them. So if we go back to A, we can see that all of these terms have the same group of variables. They all have an x, y. And so what that means is that all of these terms are like terms. And so that means I can just go and add them together. Now, obviously, you can do this on a calculator because we're just adding 7xy plus 3xy plus 5xy. Remember, when you add and subtract like terms, I'm just going to do it here. So when we add or subtract like terms, the exponents don't change. that. So the only time an exponent will change is if we are multiplying or dividing. That is the only time. When we add or subtract, the exponent won't change. So a couple people have already put it on the chat, which is awesome. We're going to keep the xy exactly as it is, but 7 plus 3 plus 5 gives me 15xy. And so by sort of following my 3 steps that I have for simplifying expressions, sorry, my screen went a bit crazy there. For simplifying expressions, I have simplified this expression. Right, so I'll leave that up there just so you've got the steps and you've got the answer, but then we'll have a look at the next one. Alrighty. So let's have a look at the second question here. Now, again, we're going to follow the same 3 steps. First thing I want to do is I want to identify my terms. Now, when we look for terms, we look for plus or minus signs. We don't care about division or multiplication. So the only plus sign I have here is that one over there, which essentially means that this is one whole term and this is another term. So I've got 2 terms in this expression. So that's identifying my terms, which is step 1. Step 2, I now want to simplify each term. And this is where I check, is there any distribution? Is there any multiplication? Is there any division? Are there any exponents that I need to deal with before I go and start adding or subtracting? And we can see here that in each of these terms, I can simplify further. Now, if you want, you can do like a little bit on the side to do your working out. Obviously, if you're a bit more comfortable, you don't have to do this. But I'm going to now go and deal with each of these terms individually and simplify them. So I'm going to do the multiplication step for each term. So if we look at term 1, which was 2x squared times x, I need to multiply this. Now, when I go and multiply, this is now going back to the statement that I made over here. It is only when we multiply or divide when exponents change. So let's maybe put in a little note here. So when we multiply, or divide, every now and then I get this right, and then not all the time. The exponents will change. English change, right? So only when we multiply or divide will our exponents change. And in this case, because I'm multiplying, I am going to see an exponent change. Now, remember, when we multiply, we can use SNV. If you weren't there for that, that's absolutely fine. So SNV stands for steps that we can do in terms of our multiplication and division. And it's dealing with the signs first, then the numbers, and then the variables. So here, we're going to deal with our signs first. I have got a positive times a positive. So that means my answer is going to be positive. I don't need to put the positive in there. I can just leave it. But I know that my answer is going to be positive. Next thing I'm going to deal with are the numbers. My numbers that I have here are 2 times, and we know that there is a coefficient of 1 here. We just don't write it in. So I've got 2 times 1. And we know that 2 times 1 is just 2. And then finally, I'm going to deal with my variables. And here, my variables are x squared times x. And because we know our exponent laws, we know that when we say x squared times x rather, I add the exponents, and so I get x cubed. And I can then do the same thing for term number 2. Term number 2 is 3x squared times x. If I look at the signs, I've got a positive times a positive, so that's still a positive. Again, I've got a 1 in front of that x, so I've got 3 times 1, which is 3. And then x squared times x, which we know is x cubed. And so what I've done here is I've simplified each of my terms. So now if I go back to my expression, this whole term 1 simplifies to 2x cubed plus this whole term 2, which is simplified to 3x cubed. And so in doing that, I have simplified each of my terms, which is step number 2. I then want to check if I have any like terms here. So you guys can put it on the chat for me if you want. Are these terms like terms? You can just put a yes or a no. Are they like terms? And remember, of course, I'll just quickly scroll up. We said that like terms are terms with the same variables and exponents. So have a look here, same variable and same exponent. Are these like terms? Right. 2 of the 3 responses are yeses, which I completely agree with. We've got an x cubed and an x cubed, same variable, same exponent. So these are then like terms, which means that I can go and add them together. And does someone want to put it in the chat, or does someone want to raise their hand? What is my final simplified answer when I add these terms? You can put it in the chat or you can raise your hand. I just want to know what is the answer. Awesome, Bridget, just put it in the chat there for us. It is 5x cubed. Remember, when we add or subtract, the exponent doesn't change. So it's going to stay x cubed. But the 2x cubed plus 3x cubes means I've now got a total of 5x cubes. And so if we follow our steps, we're going to be able to easily simplify our expressions. Okay, I'm just waiting here in case anyone wants to take a screenshot. Okay, so let's have a look at question C here. So question C, my first question to you is, how many terms are there in this expression? Now be careful because there's some plus signs inside brackets, which I don't really need to stress about. So if I look at the whole expression, how many terms do I have? Okay, I'm seeing some answers. I would definitely agree with both Bridget and Ukranyo and Wishmore. We have got 2 terms here. So this plus is the one that's important to me. I don't really stress about plus or minus signs that are inside brackets. And so what we have here is, oh golly, 2 terms making up my expression. This, okay, it didn't get any better. Term 1 and term 2. I've got 2 terms here. Now, what's a little bit different here is that it's still multiplication like there was in question B, but the multiplication looks a bit different because I've got multiple terms that I need to essentially multiply. And so what I need to do here is I first want to distribute my coefficient to each of my terms inside the brackets before I start adding or subtracting anything. So I'm going to let you guys give this a try. Because I've sort of given you a hint to start off with. We want to distribute before we add or subtract like terms. So give it a try. And then if you would like to give your answer, you can raise your hand and you can explain it for us, or you can put your answer on the chat and we can see how we go. Okay, so do your distribution first and then gather your like terms. If you have any questions as you go along, put them in the chat or raise your hand. Obviously, we're more than happy to help. Cecilia, do you have a question or do you want to do the answer?
Ma'am, I have an answer.
Okay, tell me how we're going to do this.
Ma'am, I said 5 times 2, which is 10x,
Good.
plus 5 times 3, which is 15y,
Perfect.
plus 5 times x, but there's an invisible 1 in front of the x, which makes it 6x,
Perfect.
6y.
And 6y.
Yes.
Okay, cool. Now what do I do?
Put the like terms together,
Okay.
which is 10x plus 6x plus 15y plus 6y,
Excellent.
which is equal to 16x plus 31y.
Did you say 31 or 21?
31.
So 15 plus 6 is 21y. Unless I can't do maths today.
Oh, ma'am, you're right. I was wrong. Sorry.
Right. Okay, cool. So well done, Citle. Thank you very much. What I quite like that Citle did here, and you don't have to do it, it is just quite a useful thing to do, is once we know what our like terms are, we can actually group them together so that we know exactly what it is that we're adding or subtracting. Now, again, you don't have to do it. It is just quite helpful for us so that we know which terms to add and subtract. But at the end of the day, we get 16x plus 21y. Now, importantly, so that we all know what's happening, if I go and distribute this first bracket, so this 5 times the 2x and the 5 times the 3y, that's where we get 10x plus 15y. By multiplying 5 times 2x, I get 10x, and then 5 times 3y, I get 15y. The 6 times the bracket x plus y then gives us a 6x plus 6y. And so those terms in my first step have come from the distribution. Alrighty, I hope that all makes sense. I'm going to let you take a screenshot if you need. Lafika, do you have a question for us?
Hi, ma'am. Can you
Hi.
please return to the previous question? I forgot to screenshot.
No problem. I'll do that, and then we can get, or you can get both.
Okay, thank you, ma'am.
Pleasure. Okay, guys, just in case you also needed question B, there it is. I'll leave the screen like that so that you can take a screenshot of both if you want. Okay. Right. So one more, and then we're going to take a little break. Now, this one is a little bit different because I don't want to say it's a word sum, but it's sort of like words describing some sort of expression. So this question is saying to us, subtract 5a minus 4b plus 10c from 6b minus 3c plus 4a. So basically what it's saying is I want to take this whole thing and subtract it from this term. So essentially I want to take this minus that expression. So what we can do is we can set up an expression to sort of make this make sense for us. So we're going to start with what we want to subtract from, which is 6b minus 3c plus 4a. And I want to subtract this expression. Now, importantly, because there's 3 terms here, I'm going to put brackets here because I'm going to have to distribute this negative into the bracket. So I'm going to subtract the 5a minus 4b plus 10c from the 6b minus 3c minus 4a plus 4a, not minus 4a. And so what we've done is we've essentially taken what was stated to us here, and this just looks a bit messy, by saying subtract this expression from the 6b minus 3c plus 4a. And so importantly here is reading it and understanding which expression to put first. Now that we've done that, we can go and distribute. And remember, there is actually, it's a bit of an excessive one. There is actually a 1 in front of this bracket, which means that technically I've got a -1 that I want to multiply to all 3 of my terms inside this bracket. So I'm going to give you a second, give it a try. Start by distributing the -1 into the bracket. And once you've done that, simplify your expression to see what you end up with once you have subtracted the 5a minus 4b plus 10c from the expression 6b minus 3c plus 4a. Again, you can put your answer in the chat. You can raise your hand, whatever you would like to do. But let's see what we get once we've subtracted. Obviously, guys, if you have questions along the way, just shout. Or don't shout, raise your hand, let us know. Guys, like I say, these skills that we learn here are so, so important. You're going to use simplification of expressions all the way up until matric. And you'll be doing it without even like consciously thinking, oh, I'm simplifying an expression. It's just going to become sort of something we expect you to do. Okay, Umakhara, in terms of the question, I'm not too sure where you don't understand. Maybe if you can let me know, but basically I'm going to run through it again quickly. Hopefully this helps. The question is saying subtract this entire expression 5a minus 4b plus 10c from the second expression. So I want to take this first expression away from the second expression. And so that's why I've set up this equation. I've got my first expression and I'm taking the 5a minus 4b plus 10c away from it. That's what it's telling me to do. Subtract it from the 6b minus 3c plus 4a. And so because I've sort of set up this expression, subtracting the correct one from the other, I'm able to go and simplify to get an answer here. I hope that makes a little bit more sense. If not, please raise your hand or pop me a message. Hopefully I can try help. So I'm taking the first one away from the second one. If you don't want to set it up like this, I don't know how many of you still do this. I feel like I used to do this when I was younger, but some of you might still do it. We're essentially saying 6b minus 3c plus 4a, and we want to subtract. So we want to subtract this expression from that. And so what we can do is we can sort of set it up like I'm sure there's a word for this, but I have no idea. How we would do it in sort of like junior school when we subtracted expressions. Now, obviously, I'm not like a huge fan of the fact that the terms don't match up. So what I can do is I can rewrite this to say 6b minus 3c plus 4a minus, and now we can line everything up. So minus 4b plus 10c plus 5a. I haven't changed anything. I've just put it so that the a's, the c's, and the b's line up in my subtraction process. And then I'm able to distribute the negative, same as what we're doing in sort of this step over here, in order to subtract. Okay, I haven't seen any answers, so maybe let's go through it together so that we can see what's happening. So again, I want to subtract 5a. I'm just going to take off all of the colors that it's not so distracting. I want to subtract this first expression from this second expression. So the second one has to come first because I want to subtract I want to subtract or take away from it. Cecilia, do you want to tell us or do you have a question?
Ma'am, I'm gonna try
Okay.
because what I said was 6b because we're solving the brackets.
Mhm.
So what I said was 6b minus 3c plus 4a
Mhm.
minus 5a minus 4b plus 10c.
Okay, what
Which-
happens when we times a negative by a negative?
We get a positive.
A positive. So -1 times -4b must give us positive 4b. Do you
Oh.
agree?
Yes, ma'am, I do.
Okay, now what happens with the -1 times the positive 10c?
Negative.
Excellent, well done. Okay, so now what do I do?
Put the like terms together.
Okay, cool. So what are my like terms?
6b
Mm-hmm.
plus 4b
Mm-hmm.
minus 3c minus 10c
Good.
plus 4a
Yeah.
minus 5a.
Good, well done. And now?
We simplify, which is 2b.
Why 2b?
Oh, sorry, ma'am. I completely forgot that I had got a mistake. I made a mistake. 10b
Good.
minus 7c.
So minus 3c minus 10c. What does that give us?
7c. Oh, 13. Negative 13.
-13. Good.
Plus, not, ma'am, am I right? Oh. -1.
Excellent. Well done. Fantastic,
Thank-
Cecilia. Well done. Okay, guys. So once I've distributed that negative, and very importantly, we are multiplying in a negative here. So that is going to change the signs. Look, the 5a became negative. The -4b became positive. The positive 10c became negative. And that's all because I distributed or multiplied by a negative. Once I've done that, again, I like that Cecilia is collecting like terms. It does make life easier. I collected all of my like terms together to then add and subtract. Now, it is absolutely fine for you to leave your answer like this. If you are someone who likes to put things in alphabetical order, you could write this as -a or -1a. You don't have to write the 1 here, but you can. Plus 10b minus 13c. All this is putting it in alphabetical order, A, B, C. You don't have to. Generally, we put things in alphabetical order, but you don't have to. It's not like you have to do it. Now, this was a tricky one, guys, so please don't stress if you found it a little bit complicated. What was important here essentially was reading what this question was saying to us and making sure that we subtracted the correct expression from the other. So I'll leave it up if you want a screenshot. And then we're going to take a little break before we carry on with some equations. Alrighty, I'm assuming we've got our screenshots. So our brain break today is the dingbats again, or like guess the phrase again. I think I remember all of these.
Let's have some fun, guys. Let's see. Ooh, Cecilia might have one.
I hope I remember all of them. Okay, Cecilia, what do you think?
I think number 4 is 1 whole.
Okay, very, very close. It's a hole in one. Do you agree?
Yes.
Okay, so like in golf, hole in one hole. Exactly.
Thank you.
Good. Okay, what do you think?
Ma'am, I think number 2 is baseline.
I am tending to agree with you. Baseline, because we've got the base and then we've got the line underneath. Wonderful, thank you. So we've got 2 and we've got 4, guys. Okay, do you have any others for us?
No, ma'am.
For 3 and for 5, look at sort of like, I want to say the shape, but sort of like the picture it creates. So like 5, it's sort of like, that's not great. Masego, well done. This is sort of like going up. We'll sort of leave it there. Maseko has given us number 1. It's midday tea. If you have midday tea, I always have tea. Got 2 more, 3 and 5. This is sort of like a hill. I'm really giving this one away. Hmm. 3 is hard. Okay, so 3, if we think about this, don't stress about the box. We've got a whole bunch of eyes and they're high up and they're all in a line. So we've got some eyes high in the sort of box and they're in a line. Those are my clues. Your Tando, I didn't think of that, but I would give you eyeliner. That's a good one. Okay, so that wasn't actually what the initial answer was, but I like that. Thinking off the box there. So this was high because they're all high up. IQ because it's eyes in a queue. And then, anyone want to try number 5? I've given you like a pretty picture there. I know I'm not an artist, but it is hard. I wasn't nice here. So number 5, it's a struggle, and the struggle sort of slanting up, so it is an uphill struggle. Like when something's really, really hard and it's not getting easier, we say it's like an uphill or upward struggle.
Yeah, that was really hard. I think I only managed to get baseline, guys. That's it.
Well done, guys. Just something fun. Don't stress. Like I've told you before, I'm shocking at these. I have to have the answers beforehand because I'm not great. But well done. Well done on trying. Let's have a look at some equations as we end off. I was a bit worried there that I couldn't spell equations. Alrighty, guys. So when we're solving equations, what is very, very important is that we use inverse operations. So inverse operations is basically the opposite operation of what it originally was in the equation. So if it was a plus, it now is minus. If it was a times, it's now divide, etc., etc. And importantly, because this is an equation, what you do to one side, you need to do to both sides of the equation, because we need to keep it balanced. If I'm taking 2 away from the left, I have to take 2 away from the right as well. Otherwise, I'm throwing my equation out of balance. So what you do on one side, you have to do on the other side. And if we can remember that, the equation should be quite easy. Okay, so if we look at the first question here, we've got an equation of 3x plus 2 is equal to -10. Now, the goal is always to solve for x. So sometimes what is quite useful is to highlight where x is. And you don't have to do this. Sometimes it's useful in order to see what operations we're dealing with that we need to use the inverse operation of. Okay, so if we want to solve for x, does someone maybe want to give me a suggestion of what the first inverse operation is that I can use? How can I start solving for x here? You can put it in the chat or you can raise your hand. What do you think the first thing I could do here is to start solving for x? Excellent, Bridget, well done. So the first thing I'm going to do is I'm going to deal with this plus 2. I don't really want it there. I just want x alone on the left-hand side. So what I now want to do is I want to use an inverse operation. Now, the inverse of adding 2 is to subtract 2, but I can't just do it on one side. I have to do it on both sides. And so what I end up with, and you don't have to write this out, I just want to make sure we're all clear, is 3x plus 2 minus 2 is equal to -10 minus 2. So what I've done is I've used my inverse operations and I'm subtracting 2 on both sides. What's going to happen is that the plus 2 minus 2 is essentially going to become 0. And so what happens is that I'm just left with 3x on the left-hand side. And we know that -10 minus another 2 is then -12. Right, so we're at this point now. What do you think the next step is going to be? Anyone want to give it a go? What should my next step be now to solve for x? Excellent, Sihle. We're now going to do division. So what we need to remember is that between this 3 and the x, there is a multiplication. I'm just going to use a dot to represent that. And so because I want to get x alone, I want to divide both sides by 3. Now, I can't just divide one side by 3. I have to do it on both sides. But essentially what I now have is 3x divided by 3 is equal to a -12 divided by 3. What ends up happening then is the 3 divided by 3 essentially gives me 1x or just x, which is exactly what I want. And then we've got the -12 divided by a +3. Now remember, when we divide a negative by a positive, we end up with a negative. And as Ukanyo said there, and Tandor said on the chat, we end up with a -4 because we know that 12 divided by 3 is 4, and a negative divided by a positive is a negative. So we end up with -4. Okay, so that is essentially inverse operations. I need to use the opposite operations to what I originally had in my equation in order to solve for x. And remember, guys, once you've done this, you can go and check your answer. You obviously don't have to, and obviously in a test or an exam, we don't want to waste too much time, but you can check yourself. By substituting your answer in, we can do a check. So our original equation was 3x plus 2 is equal to -10. My check is to check that the left-hand side, or LHS, is equal to the right-hand side, because if the equation is equal on both sides, it's true. I can then substitute this answer into place of x. So 3 times -4 plus 2 should equal -10. we know that a positive times a negative is a negative. 3 times 4 is then 12. So we've got negative 12 plus 2 equals negative 10. And we know that negative 12 plus 2 is negative 10. And because my left-hand side is equal to my right-hand side, I know that I've solved correctly for x. Okay, so you can check your answers. I wouldn't suggest writing out your answer or writing out your check like this, but just use your calculator quickly, substitute it in, and make sure that your left-hand side is equal to the right-hand side so that you know you've gotten your answer correct. Right, so I'll leave this up if you want to take a screenshot. Hopefully that makes sense. And then we'll have a look at question B. Okay, so if we go and have a look at question B here, excuse me. What's a little bit different here is the fact that my term with the x is now on the right-hand side. Now that doesn't matter. It's really up to you how you want to approach this. If you would prefer to put the x on the left and then solve from there, that's fine. If you want to keep the x on the right and keep solving, that's fine. It really makes absolutely no difference. So I'm going to show you both ways just so that you can see how you could do it. But let's start with if I just leave the x where it is. What that would mean is I need to deal with this plus 8. And in order to get rid of plus 8, I need to subtract 8 on both sides. And so what I end up with is a negative 4 minus 8 is then equal to a negative 3x. The positive 8 minus 8, English, makes 0. So that's gone. And I've subtracted 8 on the left. Now negative 4 minus 8 is a negative 12 is equal to negative 3x. And then this is quite similar to what we had going on earlier. I don't like the negative 3 coefficient, so I want to divide both sides by negative 3 because I know that that will cancel out the negative 3 in front of the x. So I've got a negative 12 divided by a negative 3 is equal to negative 3x divided by negative 3. That gets rid of that. A negative divided by negative is a positive. 12 divided by 3 is 4. And so x is equal to 4, or 4 is equal to x. Doesn't really matter. So you can definitely do it like that. It means exactly the same thing as x equals 4. If you're not a fan of that, that's cool. What we can do is we can bring the x term over to the left. So I'm just going to rewrite my equation. And bringing it over to the left, for lack of a better word, essentially means I'm going to add 3x on both sides. Okay. Now, if I'm adding 3x on both sides, that essentially means that the minus 3x plus 3x gives me 0. But now I've got minus 4 plus 3x is equal then to just 8 on the right. And now I start to solve my equation. So first thing I want to do is I want to deal with this minus 4 by adding 4 on both sides. So I've got 3x is equal to 8 plus 4. We know that 8 plus 4 is 12. And then the next thing I want to do is divide both sides by 3 in order to get x alone. And we know that 12 divided by 3 is 4. And so whichever way you do it, you end up with exactly the same answer. So it really doesn't matter. That was a terrible line. It really doesn't matter what you want to do, if you want to get all the x's on the left first and then solve, or just keep it on the right. It makes no difference. You will get the same answer as long as you are using your inverse operations. Okay, so importantly, guys, it is x is equal to positive 4. In the first method, you had a negative divided by a negative, which gives you a positive. Very, very important. So please remember to consider your signs when solving equations. Okay, I'm stopping there if you want to take a screenshot. I will come back, don't stress. Right, I want you to have a look then at question C, and let's see if anyone wants to suggest what my first step could be here. Remember, my goal is to get this x in the fraction alone. So what could my first step be in order to start solving for this x? Any suggestions? What operation, if we're feeling a bit stuck, let's start with this. What operation is or does a fraction represent? So if I give you a fraction, what operation am I actually asking you to do?
We can do this, my babes. Think what needs to be done. Let's go.
So if that question isn't making sense, if I gave you 3/5, what operation does that division represent? What does that mean? Yes, I also then just told you. Right, a fraction, because now I've told you, means division. So as Sihle has put on the chat there, I need to use the opposite. So I need to go and multiply. So what I'm not sort of feeling at this current moment in time is this denominator. If I have a fraction, let's just get rid of that denominator. Now, because this was originally divided by 5, the opposite tells me that I must times by 5. And that will get rid of that denominator. But I can't just, I can't just do it on the left. I also need to multiply by 5 on the right-hand side. I'm gonna sneeze. Sorry, everyone. Whew. And so by multiplying both sides by 5, I'm able to get, I don't know what I'm doing, so sorry. I'm able to get rid of that fraction. So I've multiplied the left by 5, so now I'm just left with 2 minus x. Thank you, Tando. And now on the right-hand side, because I'm timesing both sides by 5, I've got 3 times 5, which is 15. And now this looks so much nicer. What is the next thing I can now deal with, guys? I've got 2 minus x equals 15. What's the next step I can now do to solve this equation? Okay, Sihle said addition. Sihle, what are you going to add? What term are we adding? Oh. Right, I like where we're going with this. Just be very careful. This 2 was originally a positive 2, because remember, if there's no sign in front of a number, it is originally plus, which means that to do the inverse, I need to subtract 2 on both sides. So just remember that if there's no sign in front, it's actually a plus. And so we've got plus 2 minus 2, which is essentially 0. So we've got minus x on the left. It's a weird looking minus. And then we've got, didn't get any better. And then we've got 15 minus 2, which is then 13. Okay, so very nice. We do want to deal with that addition. It was plus 2, so I want a minus 2. And now I have negative x equals 13. Now, guys, remember, I don't want negative x. I want positive x. And so what we need to remember for ourselves is the fact that there is actually a negative 1 in front of this x. So who wants to tell me how am I going to get positive x as my answer? What do I need to do here? What is that inverse operation that I need to use? Excellent, Sihle. Division. This is negative 1 times x. So the opposite of that would be to divide by negative 1. The negative ones essentially cancel each other out. So maybe let's just write this a bit neater. So I'm going to have negative 1x divided by negative 1 and 13 divided by negative 1, leaving me with just x on the left. Who knows what that is? And a positive divided by negative is a negative, and 13 divided by 1 is then 13. So x here is equal to negative 13. Okay, so when we've got fractions, what we want to try and do as our very first step is get rid of that denominator, because the second I don't have a fraction, life becomes so much easier in order to solve that equation.